All right. What's good, math family? Welcome to another live stream with Algebra 1 with Mr. Peters. Just remember, we're live streaming every Tuesday, every Wednesday, 6:30 p.m. Eastern Time, going off that New York time. And today we're going to focus on factoring polynomials and quadratics. What I've done was down below, I've linked yesterday's live stream on Slope down below for you. And I put a few quadratic equations and how to solve quadratic videos down below to help you guys if you need additional resources or videos to watch. We may not get to every factoring method, especially for quadratics. So what we don't finish today, next Tuesday, we are going to finish. Really hope you guys enjoy the show. And let's get it started. So when we're talking about factoring polynomials, quadratics, the rules are very, very similar for both of those cases, okay? So typically your teacher is going to come out, right? And we know it follows the format ax squared plus bx plus c, right? We got the x squared term, the single x term, and then just the constant. So this is the standard form of a quadratic equation. And what we do is we will come out here and write the factors. And you don't really have to do this, but it makes it 10 times easier for us to get this problem right. So at this step right here, we're looking for factors that multiply to give us this 8, but add to give us this middle number. So we know from just this problem right here, my factor is going to be x and 2 times x and 4. Now, when we're talking about the signs for these quadratic equations, okay, this plus sign lets you know that your factors are both going to have the same sign, whether they're both positive, both negative, okay? So we know that from this positive 8, both their signs are going to have the same sign. And if they add to equal 6, they both have to be positive. So our first answer should be x plus 2 times x plus 4. Now, anytime you want to check if the quadratic equation is correct, just FOIL, right? I like to use the box method because I think it's faster. So x plus 2, x plus 4, x squared goes in the first box, x times 2 gives us 2x, 4 times x gives us 4x, and 4 times 2 gives us 8. After we add these two like terms, we're going to get that trinomial. Now, this is a little bit different, right? And the reason why this is different is because, yes, based off that C term, both of our signs are going to be what? Have the same sign. But if it equals to -3 when we add them, there's only one combination that would do that, right? We know both the signs have to be the same, so they probably both have to be negative. So x minus 1 times x minus 2. When we add -1 and -2, it's going to give us that -3 in the middle. Multiply these two negatives, we get that positive. All right, so this is an example when that middle term, this C term, helps us understand what our signs are without too much thinking. All right, go back to this right here. We have a plus sign, so guess what? Both signs will be the same. So I write out my factors: 1 times 14, 2 times 7. The only one that's going to give me 9 when I add is 2 times 7. So I'll have x plus 2 times x plus 7, and that will give us this trinomial back here. Adds to 9, multiplies to 14. And then when we go to our last example of the day, this one is different from the rest of them because we have a subtraction sign in front of C. And that lets us know that what? Our factors are going to have they're going to have the opposite signs. One's probably going to be positive, one is negative. For us to know which one's positive or negative, we could pay attention to this middle term. And this is what I mean. So when I go ahead and write my factors, 1 times 4, 2 times 2, right? Only this combination of 1 and 4 can give me a 3 when we add. So now that I know that, right, we have x and 1, x and 4. If we want a positive 3 in the middle, we know that the larger number, 4, has to be positive. So this would be positive, and then when we go to this side, x and 1, this is going to be negative. So once we multiply those, they'll give us the -4, right? But however, when we add, we will still get that positive 3. So this is just the first instance of factoring where we're talking about factoring regular trinomials. We're now going to move over to the greatest common factor, okay? So let's erase and let's get some more space. And family, if there's any questions or anything like that, man, just type it in the chat for me. Make sure you guys smash the like button if this video is helpful for you, okay? So we go on to our second set of questions. And let's do this. All right, what we got? So typically when we start off with GCF, we'll have binomials, right? And you guys know binomials are just an expression with two terms, right? That's the binomial. So anytime we're doing the greatest common factor, you're just trying to find the highest number that goes into both of these because we're trying to simplify. So when I look at this expression right here, I know 4 goes into both of these. So if I pull that 4 out, the greatest common factor, right? We're left with x plus 7. And this is our final answer. There's nothing more we could do to simplify that. Now in our second example, right? Negative 5x plus 30. The greatest common factor between these two numbers will be 5. All right? So we pull out that negative 5 because we want this x to be positive. And what we have left over is x. And this is, you have to be mindful when you do this too, especially when you're pulling out negatives. Because a lot of students will come in and say x plus 6, right? But when you distribute this back, you'll get the negative 5x. But when you multiply negative 5 and positive 6, you'll get negative 30. So just please make sure you check your signs, because this is an easy mistake that I see a lot of students make, okay? So this is just the basics when we're talking about greatest common factor. Now, what I want to show you for the next two examples are what you're probably going to see. And what makes factoring so complicated is the fact that a lot of these are mixed rules. You have to do 1, 2, or even 3 of them at a time. And I'm going to show you guys what I mean. So let's look at our first example, right? 5x squared minus 15x minus 140. So the first thing we're going to want to do is that greatest common factor, because it's easier to factor when that lead coefficient, or that leading term, I should say, is just 1, meaning x squared. So after I pull out 5, I'm going to have x squared minus 3x, and then what's 140 divided by 5? Okay, minus 28. So now that we did that, we did the greatest common factor. However, family, this could definitely still be factored. We could do one more step. And when I go into this right now, right, I'm looking for something that multiplies to give me negative 28, add to gives me negative 3. So me, I already know, or we know 28, we know the factors. We're working with 7 and 4. 7 times 4 gives me 28, and when we add them, we could get 3. So remember I told you about those signs. If C is negative, that means our signs have opposite signs. And if we want to know which one, if we need a negative 3, that means my larger number, 7, is going to be negative, and the smaller number will be positive. Once we add these two back together, we get the negative 3, multiply negative 28. Now, my next example for the greatest common factor, let's see, let's have another one. This is our second example. So we have 2x squared minus 8x minus 24. Yep, I think that's correct. Yep. So same thing. We look at all 3 of these coefficients. We could definitely pull out the greatest common factor of 2. So I pull 2 out, and everything gets divided by 2. So 2 divided by 2, we just have x squared. Divide this by 2, negative 4x. And 24 divided by 2 is 12. Now we're focusing on what's inside the parentheses. This is still part of the answer, but we're focusing on factoring what's inside of the parentheses. So when I look at 12, we have 1 times 12, 2 times 6, 3 times 4. The only combination that could give us this 4 is 6 and 2. And this is why your teachers tell you to write it out, because it's just easier when you can visualize it like this. So I go in, we have 2, Let's write our both our binomials. We have 6 in one of them, we have 2 in the other. Now I don't even have to think, because what? Signs are opposite. Larger number is going to take this sign. So I know as a result, my answer will be 2 times x minus 6 times x plus 2. And this should give us our correct answer. Yep, that's going to give the correct answer. So this is what we call the greatest common factor. And when we talk about the greatest common factor now, I want us to also touch on the AC method, aka slip and slide, because there's going to be times where you have a number that's greater than 1 in front of x squared, and you may not be able to divide each term by 3. How can we solve? So I'm going to show you guys how to do that. As a matter of fact, let's make sure we write this on the board for people that are joining the live right now. So we got AC method, and we also call this slip and slide, so you guys know. So let's get these problems down. Okay, so when we're using this method, family, make sure I wrote these right. I'll be moving too fast. You guys know me. All right, you guys know I'll be moving way too fast. All right, so like I said, when we're dealing with this, right, this is a instance where we have a lead coefficient that's greater than 1, and we can't pull out a greatest common factor. Yes, you can use a quadratic formula, but it's a lot of work compared to this. So when we do the AC method, remember, ax squared plus bx plus c, we're just taking a and multiplying it by c, so that this lead term is now 1. It makes it 10 times easier to factor. So once I do that step, I have x squared minus 3x minus 18, because I multiplied 9 and 2. All right, now I'm focusing on factoring this. So we got 1 times 18, 2 times 9, 3 times 6. And I think that's it, family. If I'm wrong, drop the comment down below for me, okay? So we're going to use 3 and 6, right? Because it multiplies 18, adds to 3. So now what I have is x and 6, and we have x and 3. So remember, we're trying to figure out the signs. That's the easy part. Opposite, larger number takes this sign. So 6 is negative, 3 is positive. Now, the reason why students get this wrong is because they forget to divide. We have to balance the equation, or balance our work. If we multiply it by 9, after we find our factors, we now have to come back and divide by that same number we multiplied by, or that same a we multiplied by. I'll grab my calculator real quick. Okay, so at this step, typically what happens, let's just take a pause. So if I had x minus 6 over 2, what we do is we'll simplify it to a whole number, x minus 3, right? But when we have a problem where we use this method and the top number is smaller, we have to reduce our fraction to lowest terms. So in this problem, that means this is going to turn into, oh, this doesn't look too dark. Here's that. Oh my God. My bad, family. All right, let's go back to blue. So this is going to turn into x minus what? If I divide both of these by 3, I could get the fraction of lowest terms, meaning what? 2 over 3. Now at this step, because I don't have a whole number, slip and slide, we're going to take this 3, put it in front of x. So my first factor is 3x minus 2. Same thing here. Divide top and bottom by 3. We're going to get x plus 1 over 3. Can't divide and get a whole number, right? This fraction, slip this in front of the x, the denominator it is. 3x plus 1. Now, just for the video purpose, when we multiply back, let's see what we get. 3x times 3x is going to give me 9x squared. 3x times 1 is positive 3x. Negative 2 times 3x is negative 6x. And negative 2 times positive 1 is negative 1. After I combine my like terms in the middle, this will be 9x squared minus 3x minus, oops, negative 2 times 1. That's why I got to check your work. Minus 2. So we know that these two factors are correct. And this is why I like this method, because it's 10 times faster than the quadratic formula. All right, so let's just erase this so we get a little space. Now, when I go over to this second example, same exact thing. We can't pull out a GCF because these three numbers, 3, 1, and 10, they don't have a common factor. So I'm going to use my AC method. So x squared minus x minus 30, right? Now, this is so much more easier. So I write out my factors: 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now, remember, the combination has to give us a 1. Has to be 5 times 6. So we go in x minus 6 times what? X plus 5. Don't forget, we got to go back now and divide by that same a that we multiplied by. And this is what I mean when I say if we could divide and get a whole number, we simplify. So x minus 6 over 3 turns into x minus 2 as my first factor. And in the second one, we cannot get a whole number when we divide 5 by 3. So let's slide that 3 in front of x to get 3x plus 5. And these will be my two factors. All right. So we got that done now. And now what I want us to go over to is going to be the difference of squares. Okay. And the difference of squares is important, especially for quadratic equations, because of the square root method. And I'll make sure to touch on that square root method for you guys. So let's look at this. So let's start off with the basics, right? So when we're dealing with the difference of squares, we are going to have the same exact binomial squared. So what does Peters mean, right? When you have the difference of squares, what happens is, hold on, I think I said something wrong. Let me back up. We're going to have the same factor with opposite signs. I'm sorry, family, moving too fast. Because what happens here, right? We're going to have the square root of x and the square root of 81, which you know is x and 9, and we're going to write it again and change the signs. This is how you factor the difference of squares, and I want to explain it like that. Because what happens is when the signs are flipped, that middle term gets canceled out. So let's use the box method so you see what I mean. So we have x and positive 9, x and negative 9. So x and x gives us x squared. 9 times x gives me 9x. X times negative 9 gives me negative 9x. And negative 9 times 9 gives me 81. All right, so middle terms cancel out at 0. We're left with x squared minus 81. So when you're looking at the difference of squares, understand it's the same exact factor with different signs, one positive, one negative. So when we look here, square root of x is going to be x, square root of 9 is going to be 3. I write it twice, flip the signs. This is the answer for x squared minus 9, right? But now I want you guys to understand that the difference of squares is going to be 9 times out of 10. There's going to be a subtraction sign there, okay? So something like this is prime. We can't factor that. There's no number. When you look at x plus 9 and x minus 9, first to get a positive, they either both have to be negative or they both have to be positive. And what happens is that middle term will not cancel out if both of them have the same sign. So let's say I erase this and I erase that. This will turn into x squared plus 18x after we add these two, plus 81. If it was x minus 9, and x times x minus 9 again, it will be x squared minus 18x plus 81. So understand why this is prime. There's nothing that's going to give us that answer where one is positive, one is negative, and the middle term cancels out. Now, this is just the basics. So what I want to do now is show you what you're probably going to see and then tell you guys how this relates to the quadratics. Because you'll hear something called the square root method, and it's very similar to the difference of squares. So let's say they had something like this. Let's get two examples. Okay, I got three examples. My bad, family. All right. So this will fall under the difference of squares. However, it will not look like that at first. And the difference of squares is typically a binomial. There's two terms. So when we look at that ax squared plus bx plus c, there is no bx. It's typically ax squared plus c is equal to 0. Something with this format. And when I go over to the square root method, you'll see what I mean right here, okay? But I want you guys to know there's not going to be a b term. That should be your a hint for you. Yes, exactly. Exactly, Juan. X plus 9, X minus 9. Hey, thank you for that comment, man. It's always nice when you guys drop comments for me, man. I'd be so nervous up here. So back to the difference of squares, right? So typically with factoring, it's a mixture of rules. So right here, what we probably could do is take a greatest common factor of what? 2, right? 2 goes into 200, and we notice that both of these have x's. So I could pull out a 2x. Now what is left over? I got you. X squared minus 100. Now, y'all see what I mean now, right? Your light bulb should be going off in your head. Hold up, Peters. This is a binomial, right? Subtraction sign. This is probably difference of squares. So now we break this down one more time. 2x does not go anywhere. It's still there. What does this break down to? This is a perfect square. X times x is x squared. That's a perfect square. And this is a perfect square. So I write their square roots twice, right? And now I flip the signs. So the correct answer for this is 2x times x plus 10 times x minus 10. That is it. Now, problem number 2. What they like to do is use exponents higher than 2 because we're so used to seeing x squared minus something, but that is a trick. So what could I do right now? You guys think to factor this? All right. So what we could do is x squared and 10, right? And rewrite that as x squared and 10. Because x squared times x squared is going to give us x to the 4th. And when you think about it, what's the square root of 4? It's 2, right? That's how they try to get you. So once we break this down, this should be x squared plus 10 times x squared minus 10. And this is our final answer, right? And then in the last one, this is the trick because it doesn't look like the difference of squares, right? But similar to this first problem, we have to break it down with the GCF. So 45x squared minus 5. Greatest common factor of 5. So I pull 5 out, and I'm left with what? 9x squared minus 1. Family, I'm going to be real with you. If I probably wasn't a teacher, I probably wouldn't identify this as a difference of squares. But 1 is a perfect square. The square root is 1. And we know 9 and x squared are perfect squares. So this breaks down to what? 5 times the square root of 9 is 3. Square root of x squared is x. Square root of 1 is 1. We're going to rewrite that again. And now we're going to flip our signs. And this should be our answer, right? Yeah, that should be our answer. Let's check the notes. Exactly. All right, so right now we're on the difference of squares. And what I want to do is let's go over and talk about let's see. Yeah, let's go over and talk about the square root method because it's very similar to this. So when we're talking about the square root method, hey Wong, I appreciate you for double checking my work because your book teachers make mistakes sometimes. So I'm glad to see that you're paying attention, man. Shout out to you, bro. Thank you so much for your comments. So let's say we go over to the square root method, right? And that was what I told you guys as ax squared plus c is equal to 0. Or this may be a subtraction sign. You guys, you should know what I'm talking about. So the problem that they'll give us is something like this. So this is when it's a quadratic equation and they set it equal to something. So this is an actual equation now that we're solving. So that's the first example. And let's switch colors for the second example. So remember what I told you about the square root method. It's typically going to be what? X squared term and c. There's more than likely not going to be a bx term or a middle term. So we're trying to solve for x. And just like a regular equation, we have to get x squared by itself, and we have to get rid of this exponent and figure out the two answers. So we're going to add 16 on both sides. So we have x squared is equal to 16, right? And before we go anywhere, let's just pause right here. You guys know the answer, right? If this was the difference of squares, you would say, okay, Mr. Peters, this is x plus 4 times x minus 4, which it is. But this is now an equation with just a little bit different step. And this is what I mean. So just like an equation, variable constant on opposite sides. But when you want to get rid of a square root, something to the second power, right, you have to take its square root, right? So if this is to a power of 2, I take the square root so that the square root and exponent cancel each other out. I'm left with x. If it was a cube root, we would then take the cube root to cancel the exponent and the cube root out and just leave x. You guys have to know this for this method because you're going to use it a lot in Algebra 1, okay? So now at this step, we do the same thing on the other side. This is where you get that plus or minus. So x is equal to what? Plus or minus the square root of 16, because there could be two negative numbers that you multiply to get that answer. So now x is equal to plus or minus the square root of 16, which is 4. So that's very similar to the difference of squares. You see what I mean, family? So that's why I wanted to show you these two back to back, because they're basically the same skill. This just has equal to 0. And yeah, basically. All right, so question number 2. So we're dealing with the same issue now, right? But now we notice that we have a coefficient. That's a little bit different from what we've been doing. Not really. So first step, we're trying to solve an equation. Let's isolate the variable by adding 45 on both sides. We have 5x squared is equal to 45. Now guess what? Just like regular equations, for us to get x by itself, we have to get rid of the coefficient. Let's divide by 5. X squared is equal to 45 over 5, which is 9. Now guess what? Square root method. I need to get rid of this exponent. So I take its square root. What I do on one side, I do on the other. They cancel out. X is equal to plus or minus the square root of 9. When we take this one step further, x is equal to plus or minus 3. Bam! Just like that. And that is it for when we talk about the square root method. Now, please, family, I'm not trying to rush through this, but remember, next week, I'm going to focus more on the square root method and completing the square. But this video, we're just touching on it so we could show you these skills, okay? All right, so we got the square root method. Now what we are going to try to do, do I have all my questions? All right, we're now going to go over perfect square trinomials, and I'm going to show you how that is important for completing the square. And if y'all just joining us in the live, man, smash the like button for us. And just remember, we are going to be live every Tuesday, every Wednesday, 6:30 p.m. We're going on that New York time, Eastern time, okay? All right, so now we're talking about perfect square trinomials. So we have x squared. All right, so let's see. Okay, so we're dealing with perfect square trinomials. And perfect square trinomials are basically when you multiply the same exact binomial with the same sign to itself. So example of a perfect square trinomial would be this: x minus 5 squared, which is equal to x minus 5 multiplied by x minus 5. Once we combine it, it's going to be x squared minus 10x plus 25. Okay, and this is important with the formula. I'm sorry, a squared plus 2ab plus b squared. And I'm gonna break down what this means so you understand. So when we look at this, right, this is gonna be ab. So when you look at this, right, a is squared, x squared. The middle term is 2 times x times 5. That's correct. We have 2 times 5, which is 10, times x gives us 10x. And then this last term is just b squared, which is 25. So once it follows this format, it is a perfect square trinomial. And I'm going to show you what I mean through these examples. So, let's not even erase that. Let's keep that up there. So let's look here, right? Does it follow this format? A squared plus 2ab plus b squared. Well, let's think about it. The square root of x squared is what? X, right? Let's just put the square outside. Square root of 49 is 7. So when we look at our AB, does the middle term, is it 2 times AB? Well, let's look. That would be 2 times x times 7. And that would give us 14x. So guess what now? If we were factoring this, it would be our AB. So this would be x minus 7 squared. This is our answer for this perfect square trinomial. Okay. And another simple way to think about this is take half of b and square it. Half of 14 is 7. 7 squared is 49. That's just a quicker way to do it. You guys know I'm always going to give you more than one option on solving these problems. So let's go over to here, right? Does this follow our format? And now we could erase this. I think you guys had this long enough. All right. When we look over here, square root of x squared, x. Square root of 9 is 3. Does this 6x follow that 2 times AB? Let's see. That would be 2 times x, which is 2x times 3, which is 6x. So we know that this is correct. However, just like the first problem, make sure you put the correct sign. So we would have x minus 3 squared as the answer to this perfect square trinomial. Okay, so that's our answer. Now, in this third one, when we look at this, half of 2 is 1. 1 squared is 1. So we know that this is a perfect square trinomial, but let's still do the work. Square root of x squared is x. Square root of 1 is just 1. When we look at that middle term, it follows that format. 2 times our a, which is x, and times our b, which is 1. This will give us a 2x in the middle. So my final answer will be x plus 1 squared. Okay. Now we're going to go over to the next few examples on perfect square trinomials. I don't know why I didn't write this. I'm sorry. We're going to go over to our other few examples, and the method that I use here this is the best method you want to use when we have a lead coefficient that's greater than 1. So let me show you guys what I mean. Okay, so where are my examples? Okay, here we go. So when you have a question like these two, right? 9x squared minus 42x plus 49. That's question 1. And then question 2, we have 2x squared minus 40x plus 200. So that same format you guys see me do, that's what I'm going to do. So we're talking about that a squared plus 2ab plus b squared. Like I said, when that leading coefficient is greater than 1, I think this is the best method. So let's look. Square root of 9, 3, right? Square root, and x. I'm sorry, family. The square root of x squared is also x. So this is 3x. Moving too fast. I just love this math. All right. So we go here. Square root of 49, 7. Does it follow this 2AB format to be a perfect square trinomial? Let's see. So now we draw our arrow down. We know we talk about 2 times 3 times 7. So that, I keep forgetting about x. My bad, family. So 2 times 3x, which is 6x. 6x times 7 gives us 42. So this is a perfect square trinomial. What is it? A, B. So we have 3x and 7. Middle sign is negative. This is our answer. And we can multiply it back to see. Let's just do that real quick. 3x negative 7. 3x negative 7. So this is going to give us 9x squared negative 21x. When we multiply 3x and negative 7. When we multiply 3x and negative 7 again, we get negative 21x. And negative 7 times negative 7 gives us that positive 49. So after we add these two like terms in the middle, this will give us the same exact trinomial. So we know we factored that completely. And then when we go over to our second example, right? Same method. Square root of, hold on, did I do this one right? Let's see. Okay. I knew there was something up. So family, remember I told you they're going to mix these rules. So 2 is not a perfect square, right? So what we could do, let's pull out the greatest common factor. So we pull 2 out. We're left with x squared minus 20x plus 100. Let me make sure I did that right. Something just feels weird. Okay, no, that's right. That's right. Now, let's check this. Now, let's see. Is this a perfect square trinomial? So we know the square root of x squared is x. Square root of 100, we know is 10, right? Does this middle term follow that format? So we're talking about 2 times AB, which is x and 10. So this is going to be, that's going to give us the 20x. So we know this will be 2 times x plus 10 squared. And this will be our final answer. Let's double check the notes. Oh, minus. That's why you got to check your work, family. X minus 10 squared. So this is how we would factor perfect square trinomials. And this skill is very important for our last question of this live stream, which is completing the square. And I'm going to show you guys how to do that. And like I said, this video has been helpful. Smash the like button for us. And let us know if you have any questions before we end this live stream. We want to open the floor just in case there's anything we want to make sure that we touch on. Again, my boy Wong, if you're still on here, man, let me know if you have any questions. It seems like you know this stuff and you're practicing and you're doing good. So let's keep up the good work. All right, so let's talk about complete the square. So the perfect square trinomials lead up to this skill. And if you're good with those, then you're going to be very good with this skill as well. So let's flip over to this last problem of the day. So this is what they give us. So we have x squared plus 8x plus 4 is equal to 0. So family, when you come in here and you write out your factors, right? 1 times 4 and 2 times 2. None of those combinations, when we add them, are going to give us this middle term. Yes, we could use the quadratic formula, but we're trying to use methods that are simpler and faster. So what could we do? Sorry, y'all, I'm gonna get a quick sip of water. So this is what we could do. Do I want to change markers? Nah. All right, so what we can do is to create a perfect square trinomial, right? Meaning we're gonna have to move this 4 to the other side. So once I do that, I have x squared plus 8x is equal to -4, because we had to subtract this to cancel out on one side and move it to the other. Now we have to create a perfect square trinomial so that we could answer this question. So the way that we do it in this type of question is we're going to take half of this middle term. So half of 8 is 4, 4 squared is 16. This is how we'll complete the square, right? And then if we add 16 on this side of the equation, we have to do it on the other side. Okay? So what is the factor for this perfect square trinomial? What you could do is just take half of this term, x plus 4 squared. But if we did the formula that we're doing before, let's just do it. X squared, right? We know it's going to be x. 16 is 4. And then in the middle, it follows that 2 times a, which is x, times b, which is 4. So we know for a fact that this is correct. X plus 4 squared. It follows that format. And the shortcut, take half of this, 4, square it, make sure you add it on both sides. So we have x plus 4 squared is equal to -4 plus 16, which is 12. So now for us to finish this problem off, we have to get rid of the exponent. So what you guys think we have to do? Yes, we did it earlier, which is the square root method. So I'm going to take the square root of x plus 4 squared to cancel out that exponent. So I'm left with x plus 4. And you guys know what? Got to do it on the other side. So now we have x plus 4 by itself is equal to what? Plus or minus the square root of 12. After you guys have your radical lesson, you guys should know that 12 breaks down to the square root of 4 times 3. And because 4 is a perfect square, this simplifies further to 2 radical 3. So now we're saying x plus 4 is equal to plus or minus 2 radical 3. But is x by itself? Absolutely not. So now we have to subtract 4 to get x by itself. So my final answer would be x is equal to -4 plus or minus 2 radical 3. I would always tell you to put this term in front of the plus or minus, even if this is a whole number. It's typically better to do it that way. And this is going to be the answer by completing the square. So next Tuesday, we're going to go more into the square root method and completing the square to factor quadratic equations. But the rules we went over today, family, these are the basics for polynomials, which you'll also use for quadratics. So I'm going to check the chat. And if anybody has questions, or if there's another question you want me to do or go back to, I'll give you guys about 2 minutes to let me know. If not, family, man, thank y'all for supporting our channel and jumping on our live streams. Really appreciate it. And remember, every Tuesday and Wednesday, 6:30 p.m., we'll be back. So I'm going to check this live stream and we're going to see what's going on today. Thank you guys again. All right, family. So we replied back to the chats. Doesn't seem like anybody has questions, so I'm gonna give you guys another minute. Like I said, thank you guys again for joining us on Algebra with Mr. Peters. Really hope you liked this show. Smash the like button on your way out. Drop a comment if you found it helpful.